Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph a few rational functions that are in the family of 1 over x. So we'll start with the most basic one first, f of x equals 1 over x. When we're done, we'll state the domain and range, and we'll talk about the intervals where the function's either increasing or decreasing. So first, the graph 1 over x has a vertical asymptote on the y-axis. So I'm going to use a highlighter to show that. And so again, that is a vertical asymptote. And that is at x equals 0. The function's undefined there. And what we're going to see is on one side, it's going to approach the y-axis heading up, the other is heading down, but technically they're both heading down. Anyway, the horizontal asymptote is the x-axis. And so that is y equals 0. That means as the graph, as we move to the right and to the left, it's going to approach that asymptote. It's going to get closer and closer. Here, it won't actually touch it because 1 over x equal to 0 has no solution. All right. In terms of points, the best point to start with is 1, 1. We know that if we put in 1 for x, then 1 divided by 1 is also 1. So we've got a point at 1, 1, and I kind of treat it like a turning point. What we're going to see is that when x is 2, we get 1/2, or 0.5. When x is 5, we get 1/5, or 0.2. It's getting closer and closer to that x-axis on the right-hand side. So zooming in here, when x is 2, we would get 1/2. When it's 5, we would get 1/5. It's going to get closer and closer to this axis the further and further over we go. Now it never touches it, but it gets closer and closer as we go to the right. When x is 1/2, 1 over 1/2 is 2. And what we see is that the graph will get closer and closer to the y-axis as we head towards the left. So that is the right branch of this. The other branch, if we use -1 for x, 1 over -1 equals -1. So it's going to be symmetric. If we put in -y for y and -x for x, we'll see it's symmetric to the origin. This is -1, -1, and the same kind of thing is going to happen here. Approaches the x-axis as we move to the left, approaches the y-axis heading downward as we move to the right. So that is the graph. We need the domain and range. The domain is the set of all real numbers except for 0. Because of that vertical asymptote, the function's undefined there. And the range, right, we've got arrows heading up and down in both directions, except it never quite hits that value of 0 for y. So the range is the same. -infinity to 0, union 0 to infinity. All right, so that's the, where is it increasing or decreasing? So as we read this graph from left to right, on that left side branch, that's decreasing, right? It's going down to the right. And once we jump over the vertical asymptote, this top part also is coming down from the left to the right. So this is actually decreasing over the entire domain. Which again was from -infinity to 0, union 0 to infinity. So that's the basic graph of 1 over x. The things that are going to change, it may be stretched by the number in the numerator if it's different than a 1. It may be flipped over if that number above the x is negative, and it can be shifted left or right or up or down, depending. And when we shift it, we'll shift the asymptotes with it, and then we'll find those kind of two turning points, and then we'll draw the rough curve from there. So I've got two more examples. The first one is f of x equals negative 4 over x. So instead of being like this, it's going to reflect over the x-axis. So it's going to actually look like this instead. The 4, we'll see, will stretch the curve out. So when we plug in 1 for x, we're actually going to get negative 4 instead of positive 1. And when we plug in, say, 4, negative 4 divided by 4 is negative 1. So we can find some points that it goes through pretty easily. So I'm going to go back to the idea of a table of values after I put on the asymptote. So and again, that is a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And we should be working in that quadrant and that quadrant. Let's go after it. So first, I'm going to start on the right-hand side with x and then negative 4 over x. So when x is 1, negative 4 divided by 1 is negative 4. So we've got a point at 1, negative 4. When x is 2, negative 4 divided by 2 is negative 2. Now I'm picking numbers that I can divide into 4. So when I try x equals 4, negative 4 divided by 4 equals negative 1. And now we've got a pretty good idea of how this curve goes. And because of symmetry about the origin, we're going to see the same kind of thing. When x is negative 1, we'll get 4. When x is negative 2, we'll get 2. When x is negative 4, we'll get 1. Like that. The domain and the range are the same as the last graph we did. For the domain, everything except for 0. For the range, everything except for 0 because it does not hit that value of y equals 0. And then finally, this graph is increasing everywhere because as you look from left to right, that first branch at the top left, up here, as we go from left to right, that's increasing, it's going up. And then when we jump over the vertical asymptote and we go left to right, it's still increasing. So this is increasing everywhere where it's defined. One last one, and this one's going to mix together a few things. We've got 5 over x minus 2, and then we're adding 3 to the end of that. So the 5 is a type of stretch. The 2 in the denominator tells us that it's going to move 2 to the right because it's x minus 2. Whatever we're subtracting in the denominator, that is the horizontal shift. And because the number we're subtracting 2 is positive, that means that we move to the right. The number added on to the end, that's our value of k. And here, because it's positive, we're moving up 3. So the first thing I'm going to do is I'm going to draw my new asymptotes. I'm going to move 2 to the right from the x-axis, like so. And then the horizontal asymptote, that's going to get shifted up by 3 units, like that. So again, vertical asymptote, x equals 2, horizontal asymptote, y equals 3. Now, when it comes to plugging in points, here I want to pick a value of x that's going to make the denominator 1, because I can divide 5 by 1. And so that value of x that will make that work is 3. And then we're going to do 5 over x minus 2 and then add 3 to that. So that becomes 5 over 1 plus 3. And that's 5 plus 3, or 8. So when x is 3, y is 8. I'm going to pick another point so that I can divide by 5 by that number. And the only numbers that go into 5 are 1 and 5. So I need a denominator of 5. X minus 2 equals 5 goes along with x equals 7. So 5 over 7 minus 2 plus 3, that's 5 over 5 plus 3, or 1 plus 3, which is 4, over to 7, 4, and sketch it so it approaches those asymptotes. For the other side, I need values of x that are going to make the denominators -1 and -5. And so if we start with 1, because I know 1 minus 2 equals -1, I would have 5 over -1 plus 3, which is -5 plus 3, or -2. So when x is 1, I'm down at -2. And then finally, I need a value in the denominator for x that's going to make that denominator -5. And -3 does the trick. -3 minus 2 is -5. 5 divided by -5 is -1. So I've got whoops. There we go. I've got -1 plus 3, which is +2. So at -3 for x, we're up at +2. Draw the curve through those 2 points, approaching the asymptotes. All right. This is a decreasing function everywhere. Right? Both branches are decreasing. When the number in the numerator or in front of the function is positive, it's always a decreasing function. And when it's negative, it's increasing. The domain here, now we know that it cannot equal +2. So the domain is everything except for 2. And again, we measure that from left to right. As we go from left to right, the problem shows up at x equals 2. For the range, we measure that from the bottom to the top. And where do we run into trouble? We run into trouble when y is 3. So the range goes from -infinity to 3, union 3 to infinity. Right. And again, as I mentioned, this is decreasing everywhere. Right. I hope that helped you out. In the next video, we're going to take a look at a function related to 1 over x a little bit. It's going to be 1 over x squared.